Welcome to Chapter 2 of Physics 130. In Chapter 2, we will confine ourselves to the discussion of kinematics in one dimension. So in this chapter, in summary, you will learn how to solve problems about motion along a straight line. So we'll just move along a straight line. So let's talk about the details. So by the end of this chapter, you will be able to define position, displacement, and distance traveled. So we have to be able to precisely tell the difference between position, displacement, and distance. They are not the same thing. They are different quantities. They have the same dimension, but they're different. They're not the same quantity. We will be able to calculate the total displacement given the position as a function of time. So you will be given position as a function of time and then asked to find the total displacement or maybe the total distance. Okay. We should be able to calculate the average velocity given the displacement and the time elapsed. Explain the difference between average velocity and instantaneous velocity. Describe the difference between velocity and speed. Again, they are different quantities, and the difference will be even more pronounced in 2 dimensions and 3 dimensions, the difference between velocity and speed, that is. Calculate the instantaneous velocity given the mathematical equation for the velocity. Calculate the speed given the instantaneous velocity. Calculate the average acceleration between 2 points. Calculate the instantaneous acceleration given the function form of the velocity. You will see that we will need our calculus skills here, specifically differential calculus, derivatives. Explain the vector nature of the instantaneous acceleration and velocity. Both acceleration and velocity are vectors. And we'll discuss vectors in much more detail in Chapter 3 and the subsequent chapters. Explain the difference between average acceleration and instantaneous acceleration. We'll also find instantaneous acceleration at a specified time on a graph of velocity versus time. So you're given a graph of velocity versus time. You should be able to tell what the instantaneous acceleration is based on that graph. It will be the line tangent because it's the derivative. We will see derivative of velocity with respect to time is the acceleration, and it will be, as you know, the derivative is the slope of the line tangent at that particular point. And we need to be able to identify which equations of motion to be used to solve for unknowns. So we will focus basically in motion at constant acceleration. What we'll see, we'll have 3 main equations that we will use, and we should be able to build our skills to be able to determine which equation is most useful for that particular situation. And then if you have 2 objects that are moving, how are you going to solve? Like, for example, let's say an object is at rest and another object passes by it, and then that object starts to pursue it, and then you're given the acceleration of the object that started to pursue, and the question is, after how many seconds will it reach it? At what speed will it reach it? And then when do they meet? At what time do they meet? All right, then we will focus our attention to free fall, where the acceleration is g, equal to negative 9.8 meters per second per second. We will focus our attention to that. It is motion at constant acceleration, but it's very important because we see it in everyday life, so we will focus on it. Okay? We'll describe how the values of position, velocity, and acceleration change during a free fall. We will solve for position, velocity, acceleration as functions of time when an object is in a free fall. We will have basically, again, 3 main equations. Okay? And you may recall them from your previous physics course. because it's a prerequisite that you have taken a physics course before you take this course. We will derive the kinematic equations for constant acceleration using integral calculus. So now we will go in reverse. So at first, you're given position, find the velocity. How about if you're given the velocity, how are you going to find the position? Or if you're given the acceleration, how are you going to find the velocity? That's when we reverse the situation and we use integrals to do that. Okay? We will use, again, integral calculus to analyze motion. And then we will find, for example, if you're given the acceleration, how are you going to find the velocity as a function of time? It will be the integral. Okay, so v of t is basically the integral of the acceleration with respect to time. Integral of the acceleration with respect to time. We'll talk more about details in the videos that come. And then similarly, we will find the functional form for the position versus time given the velocity function. Okay, and these topics will stay with us for the rest of the semester. So we need to get down this chapter really, really, really well, this chapter 2,